Okay, in our previous lectures, we were discussing about what is a reactivity series and how it was designed. We discussed the reactions of the metals with the water, if any, then with the steam, water means cold water, then steam, then with the acids, and then we rank the metals in order of reactivity. These were the objectives of our previous topic I taught you on Thursday. Now, today's objectives are we are going to discuss from the reactivity series what predictions we can do about the reaction of the metals with carbon, hydrogen, or the stability of their compounds. In short, we are going to discuss the applications of reactivity series that if we have designed a reactivity series, we have arranged the metals in order of their reactivity by looking into the reactions of the metals uh, with steam, cold water, hydrochloric acid, or any other acid. Our main focus was on hydrochloric acid because that's a mild acid that doesn't give any aggressive reaction, explosive reactions, uncontrollable reactions. So we studied the reactions with hydrochloric acid, and then looking into the results, we arranged the metals in an order, and that order was giving us a reactivity series. Now, looking at the reactivity series, we can what predictions we can do about the reactions. We can find out whether a metal will displace other metals. That is the first application. We can look into whether a metal and oxide of another metal will be able to react. We will be able to look into, see the first objective of today's lesson, that reduction of the metal oxides with the carbon, if any. Like looking at the position of the metal in the reactivity series, we can predict whether a given metal in the form of its oxide can react or reduce with carbon. Now, what is reduction? What is a metal oxide? How we can predict? We are going to discuss everything further in the lecture. The second objective we are going to meet is we'll see or predict whether a metal oxide will be reduced with the help of hydrogen or not. And then the third objective, which is describing the reaction of the heat on the metal carbonates, and we will see whether will relate their thermal stability to the reactivity series, and this objective we are going to meet tomorrow. So today we are going to discuss these two objectives. Now let's move further and see. Okay, reactivity series is in front of you. The easiest way to memorize the reactivity series is to memorize this sentence. That is, please send cats, monkeys, zebras into lovely, happy cages soon. So if you memorize this sentence, it will be easy for you to memorize, to remember this reactivity series. See, please, that P stands for potassium, send, S stands for sodium, cats, C stands for calcium, monkeys, M stands for magnesium, Z for zinc, into I for iron, lovely, L for lead, happy, H for hydrogen, cages, C for copper, soon, S for silver. So these metals are arranged in the form of reactivity series from most reactive to the least reactive. See, this is the most reactive, moving downward, we'll go to the least reactive. Means the one which are present at the top are the more reactive, and coming down to the reactivity series, we'll find the least reactive. Here, these are least reactive, and then at the top, most reactive. So how, looking at the reactivity series, we can predict whether a given metal in the form of its oxide can be reduced with carbon. I'm using the word reduction, so I'll again repeat the definition of reduction. Reduction is the gain of electrons, right? Gain of electron is called as a reduction. Gain of hydrogen is called reduction. Loss of oxygen is called reduction. So these are the three definitions. So if a metal oxide is reacting with carbon, and if this metal oxide is present above magnesium, including aluminium and zinc. So above zinc, I'll say, So those metal oxides. Now what is metal oxide? Reduction, I have already given you the introduction. So metal oxides, the oxide means the oxygen is combined with the metal. Like if I'll combine calcium with oxygen, that will form calcium oxide, CaO. If I'm combining reacting magnesium, if I'm talking about the oxides of magnesium, then it is MgO. If I'm talking about aluminium, then it is Al2O3. Zinc is ZnO. So the metals which are present in the reactivity series above zinc means potassium, sodium, calcium, magnesium, aluminium, and up till zinc. These metal oxides cannot be reduced with carbon. Now, what is the reason? To understand this reason, I'll go further, and here again we have arranged the metals by reacting them with the cold water steam acid, and today we are going to discuss the using the reactivity series by observing the reaction of the metal oxide with carbon and hydrogen, and then the action of heat. On this topic I'm going to touch tomorrow. So we are going to discuss just today the two topics, the possibility or the prediction of the reaction between metal oxide with carbon or hydrogen. So on what basis we are doing it? Reduction of metal oxide with carbon. We are discussing this topic, and reduction means if we are removing oxygen from certain element, certain compound, for example, the metal oxide, so that means the metal has been reduced. If the affinity of carbon with oxygen is in a way that it forms carbon dioxide and metals become separated, so it means this metal has been reduced. So in this lecture, the reduction, the focus is on removing oxygen from the metal oxide. Now what metal oxide is? The compound of the metal with the oxygen is called as metal oxide. Like you can see on the screen, magnesium's metal oxide is MgO, copper's is CuO. As I have already told you from the reactivity series, those elements which are present above zinc cannot be reduced with oxygen. Why? What is the reason behind it? The reason is I will go back to the periodic table and will recall the information where we discussed that metals, after losing the electron, they form a positive ion. So positive ion, the more the reactive metal is, the more easily it will form a positive ion. So going back, here you see the most the reactive the metal is, the more easily it form a positive ion. So these are the one which will easily form a positive ion. How it will form a positive ion? By losing the electron. So it means these metals can easily lose electrons, so they are more reactive. The one which are present above zinc, so including zinc, up till zinc, they do not show any reaction with carbon because they are very reactive and the oxides are very stable. So carbon is a weak element. It cannot reduce them. So to reducing these elements, we need to do electrolysis. So why we need to do reduction? Reduction is done to extract the metal from their ores. Now what are ores? Ores are the compounds of the metals which we are extracting by mining from the underground earth surface. So from where these metals are coming, which we are using in everyday life, these metals are mined from the earth surface. So they are not, when they are mined at that time, they are present in the form of their compounds. Some are present as oxides, some are present as sulfates, carbonates, in different form of their compounds. So we are talking about just the metal oxide. So if we want to separate a metal from its oxide, we need to fuse it or burn it or reduce it with carbon. So only those metals can be reduced which are less reactive. So carbon can be used to reduce the metal oxides to extract the metals from their ores, like this. Now see, zinc, magnesium is a reactive metal. So when we will reduce it with carbon, there will be no reaction. We cannot reduce magnesium with carbon. So to reduce magnesium, we need to do electrolysis. Now electrolysis we are going to discuss further in our lectures. For now, when we'll study the extraction of metals, then I'll explain you what electrolysis is. Right now, you just need to remember and understand that the less reactive metals can be reduced to their metals by combining with or reacting with carbon. So carbon dioxide is formed and copper becomes separated. So most can see the reduction of the metal oxide with carbon can be used to compare the reactivity of the metals, right? And the most reactive a metal is, the more difficult to split its oxide. See, it is a reactive metal, so it is difficult to split it, oxides. So magnesium cannot be reduced by carbon, so there is no reaction. But copper can be. So copper reacting with the carbon will give us copper oxide reacting with carbon will give us copper and carbon dioxide. So copper oxide is reduced to copper. So magnesium being a more reactive metal than the copper in the reactivity series, its oxide did not decompose when heating. So it cannot be extracted from its ore by reduction with the carbon. So what are we seeing next is the how can we do this? These apparatus, the mixture of the metal oxide and carbon, the wire gauge, the burner, and then when heating it, and then what happens? Carbon dioxide is formed, which is a gas that is exhaled, and what happens? The metal separates here in the container. Okay, now the importance of this reaction is metal oxide with the carbon, as I have already explained you that the importance of this reaction is to extract the metal from their ores. Now when I'll read it, you will understand. Metal, just give me a second. Metals below magnesium in the reactivity series can be reduced by carbon. They are writing below magnesium, but I would say you can include aluminium and zinc into it. So metals can be extracted from the ore by reduction with carbon. Include metal from zinc to silver in the reactivity series, and oxides of the metal above zinc in the reactivity series cannot be reduced by the carbon. So if you are given a mixture of copper oxide and zinc oxide, then zinc oxide cannot be reduced by heating it with carbon, but yes, copper oxide can be reduced, as we have seen in the reaction. So importance of this reaction is oxides of metal above zinc in the reactivity series cannot be reduced by carbon because they are very reactive. Their oxides, the compounds are very, very stable. So these metal oxides are very stable and they reduce by electrolysis. So these are the applications of this reaction. If you would write that down, note that down in your notebook. Now the next is the reduction of the metal oxide with hydrogen. Now you're already familiar with what is reduction, what is a metal oxide, why we are doing it. So now we are going to see that reaction with hydrogen. So if commonly we know that when hydrogen reacts with oxygen, water is produced. So same is going to happen here. Hydrogen when passed over metal oxide, what will happen? Hydrogen will act as a reducing agent. We have already studied in the oxidation reduction chapter that whenever a certain substance or element is reducing the other compound or oxide, like the metal oxide, then that substance is a reducing agent. And if a substance is oxidizing the other substance, then that is an oxidizing agent. So hydrogen, as it is reducing this compound, like this is a metal oxide, iron oxide, Fe2O3. So what happens? This hydrogen is acting as a reducing agent because it is reducing this iron oxide into its iron, like its metal oxide into metal, and water is produced as a byproduct. So metals above iron in the reactivity series, their oxides are not reduced by hydrogen. So those metals which are above hydrogen, the metal which are above iron, the one which are above iron are zinc, aluminium, magnesium, calcium, sodium and potassium. They cannot be reduced with hydrogen. They will be, as we have already discussed, some will be reduced with carbon, and the one which are below hydrogen are reduced with hydrogen, like mercury, silver, platinum, gold. Right, so these are the reactions. Now let's see that this is the apparatus. Hydrogen is through this inlet, will allow the hydrogen gas to go in, will heat it, metal oxide is here, hydrogen will react with the oxygen, and water in the form of steam will be exhaled as heat is provided. So the water vapors will be produced and steam, this will go out through this opening and metal will be left here. So this is the summary table. If you want to note it down, the metals which are above magnesium, like you can include zinc into it, they are heated, metal oxides are not reduced with the carbon, they are done by the electrolysis, and the one which are below zinc, they are heated and these metal oxides are reduced by hydrogen, and these ones are heated metal oxides are reduced by carbon, and these metal oxides are reduced by hydrogen, and these are the one which are present the top more reactive. They are not even reduced by carbon, not hydrogen, but the one which are below zinc can be reduced with the carbon and hydrogen. And among those, we know that iron, lead, and the one which are present above hydrogen can be reduced with carbon, and the one below hydrogen can be reduced with hydrogen. Simple way to memorize it is just to look at the reactivity series and see the one which are present below hydrogen can be reduced with hydrogen, and the one which are present above hydrogen can be up till iron, copper, lead, they can be reduced with carbon, and the one which are present at the top, which are most reactive one, can be reduced by electrolysis, like their metals can be separated from their ores by electrolysis, and we are going to discuss electrolysis in detail in our further lectures. So in today's lecture, I'm going to review. We have discussed these 2 points. We have used the reactivity series to predict whether a metal oxide can be reduced with the help of carbon and hydrogen. We went through these reactions, examples that magnesium more reactive cannot be reduced, and the copper, which is quite an unreactive or less reactive, not unreactive, but less reactive metal, can be reduced with carbon. And this was the apparatus. This is the importance of this reaction. Like these metal oxides are very stable. By looking at the reaction, we can predict that they can be, which metal can be reduced by carbon, hydrogen, and which can be reduced by electrolysis. And we can also predict the stability of their compounds. This was another reaction, reduction with the hydrogen we saw, and the apparatus we saw, and then the summary we discussed. If you have any question, you can ask me.